9 out of 10 people reach for this pen with the same hand, and science still argues about why. If you asked a crowd to raise their writing hand, about 90% would lift the right and roughly 10% the left. That split shows up across cultures and across history. Even when societies tried to train left-handedness away, the ratio bent but never broke. That consistency tells us this isn't a habit or a fashion, it's biology showing through. The first clue sits inside your head. Each hand is controlled mainly by the opposite side of the brain. The left hemisphere sends signals to the right hand, and the right hemisphere controls the left. Those signals cross over deep in the brainstem, so your dominant hand is a visible hint about how your brain organized its motor circuits. The hand you write with is the one whose control networks became faster, smoother, and more precise. What's striking is how early that preference appears. Ultrasound studies show that many fetuses already favor one arm. Some move one hand more than the other, some consistently suck the same thumb. These patterns show up months before birth, long before practice, teaching, or imitation. They don't predict handedness perfectly, but often enough to make one thing clear. Your brain is already leaning to one side while it's still being built. That early lean connects to a bigger idea called brain lateralization. The two hemispheres aren't identical copies. They tend to divide up work so the brain runs more efficiently. In many people, language leans toward the left hemisphere, while spatial attention and face processing lean more to the right. This division reduces traffic, like assigning different jobs to two teams instead of making both do everything. Left-handedness fits into this picture. It doesn't mean the brain is flipped or backwards. It means the division of labor followed one of several valid layouts. Left-handed people show more variation in how tasks like language are shared between hemispheres, sometimes using both sides more evenly. It's flexibility, not a flaw. Genes play a role, but not the simple kind people expect. There is no single lefty gene. Handedness is influenced by many genes, each adding a tiny push. Together, they bias the odds, usually toward the right hand. Think of it like a weighted coin. For most people, the coin is weighted to land right-handed, but it can still land the other way. That's why handedness runs in families without being strictly inherited. Development fills in the rest. Early brains grow fast, and small differences matter. Timing, hormone environments, and the way neurons migrate and connect can all tip the balance. Even identical twins with the same DNA don't always share the same dominant hand. Chance is part of the process, baked into how complex systems build themselves. So why does the world settle near 10% left-handed instead of 50-50 or almost none at all? One idea points to coordination. When most people share a dominant side, it's easier to design tools, teach skills, and work together. That pressure favors a majority, but rarity can also help. In competitive situations, from sports to combat, being uncommon can be an advantage because opponents are less prepared. Those two forces together can stabilize a minority that never disappears. Culture can hide handedness, but it can't erase it. For centuries, left-handed children were forced to switch, especially for writing. That changed what people practiced and reported, not the underlying brain preference. Many of those people remained left-dominant in other tasks their whole lives. In the end, being left or right-handed isn't a glitch. It's the outcome of brain wiring, genes, development, and a bit of randomness working together. Your dominant hand is the simplest map of how your brain decided to specialize.